Okay, thank you for coming. My name is Ronen Friedman. For the last 3 years or so, I'm maintaining the Scrub code I'll have to stand here, I think. For the last 3 years or so, I'm maintaining the Scrub code in Ceph. I'm not the only one who is working in this area. Others have contributed. Shreya is here, and Sam is somewhere, and a few other people have contributed to this code. And I would say that during this period, we made some improvements to scrubbing. Some of those improvements are visible, and you probably not, if you're using a newer version of the code of Ceph, you probably notice them. If not, I'll show some of those things now. But it's funny settings where I have to move slides in both places. 1 second. Okay. So, okay, good. Here's a partial list of things that I thought that are noteworthy in what we're doing. Things that made it into Quincy and Reef. I'll mention, for example, we now have clear and timely updates of the Scrub status, where we are, how many objects were done. Ashwaya contributed to this. Some as did the rest. But we made sure that updates are sent every few seconds, and watching, using for example, the operator commands pgdump or query commands, even better, you'd get up-to-date information about where scrubs are and what is scheduled. A change which is important, and I will have a slide, I hope to get to it in time. How long do I have? I forgot to note the end time. If someone can check the schedule and see what's the last moment. So it's been
40 minutes.
40 minutes, yeah, okay. So an important issue is the chunk size, and I'll have a slide about it. I think it's important for you, if you're a Ceph user, to know about this change. You might want to play with the settings that are involved. If some of you were in the Shreya's and the Sridhar presentation earlier, the DM clock, the new scheduler, makes my life easier, because I can do a lot more in Scrub without worrying whether I'm going to kill a client I/O. It also means that you, if you are managing a cluster, have more freedom to change and play with settings that affect and improve Scrub performance without worrying too much what you are doing to your client's work. So it really makes things much easier for me. Okay. Now there are a few changes that are part of more general things we are trying to do. That's the stored unblocked object warning, which already exists in versions that we have now. We have some slow replica warnings. If a replica is much slower than her co-workers in responding to Scrub requests, some Scrub requests, it will be notified. This was introduced because this is something that happened to clients, mostly, at least in the instances I've seen, because of faulty networking. But this might happen, and it's hard to diagnose. We have a few other things, like detecting some SnapDB issues that were caused by upgrade. But all in all, what we are trying to do, and we'll continue doing in the couple of next versions, is to add more detection, more ways for Ceph to detect, to warn, and maybe even to remedy issues with timeouts and slow responding parts of the system, trying to overcome problems that are not necessarily Ceph-related. Hardware issues, network, bugs in other places, or bugs in Ceph, in Scrub. It happened. More so than now that I'm doing it, working on that, but it happens. So this is an effort that started. You see the results already. It will continue. But what I'm going to invest the rest of the less than 40 minutes left is a new design of the Scrub scheduler. So first, don't be offended by this slide, telling you what scrubbing is. I know that most of the people here know more have more experience with Ceph than I do, but just that we have a common vocabulary. In Scrub, we are validating data, metadata, in case of shallow scrubs, and check some actual data, if we're talking about this scrub, between the primary and the replicas. That's, I think we all know. And there are some defaults. Shallow scrubs, because they are much cheaper to do and fast, the default is daily. For deep scrubs, it's weekly. I know some clusters push it farthest, but they should be performed. But if you're looking from inside, from my point of view of the code, there are multiple levels, multiple types of scrubs. Now, you don't have to remember this list unless you're going to write scrub code, but I'm trying to make a point here that there are multiple levels, multiple types of scrubs that correspond to the multiple triggers we have to starting scrubs. Now, mainly there are two main types. One of them is the periodic scrub, and in a normal situation, most of the time, this is what I expect, the only type I expect to see in a cluster. Scrubs that are performed because enough time has passed in the last time a scrub was performed. Okay? And that's the internally it's termed the periodic scrubs. And then we have a set of various types of high priority scrubs that are caused by sometimes problem events, sometimes by an operator command. And the type here, if you notice the list and what the names here, the scribe type affects a few things. First, like you see here, the urgency. Or we talk about urgency a lot in a few minutes. Or with urgency, I mean how fast do we want to scrub to perform this scrub. Now, it also affects when the scrub is allowed. There are restrictions that you can set. It affects some specific behavior attributes of the scrub to be performed. For example, if we are if an operator issued a command to scrub with do repair, we are doing repair. Oh, okay, we have some attributes that affect the next scrub. Now, I'm not going to go into more details here, but we'll get back to this table, which is the main part of the talk, in a second. But first, just again, to get you all into my very code or PG specific point of view. This is a life of a scrub. And I'll use this. You can see here the various PGs in this example. And let's suppose that OSD4 on a tick, which is where we on a timely tick, when we decide that we should perform a scrub, selects, let's say, PG 2.5 for scrubbing. And as you can see here, 2.5 has two replicas on OSD2 and OSD0. The first step is to ask those two OSDs for resources. Scrubbing is hard work, and we are trying to limit, like we said, the effect on the cluster. And so there is limited amount of resources that we are dedicating to scrub. And in this case, we are asking those OSD to assign us some of those resources. We return to this because this is a point of failure. And then, supposing everything went right, we are looping the PG. The PG code for running for PG 2.5 loops over all the objects, chunk by chunk. And chunk by chunk, I mean a consecutive range of objects. Validates what it knows about those objects, and requests the replicas to do the same, and then we compare nodes. Okay, I think we all know that's what's done in Scrub. Because I'm afraid that I'll be pressed for time in the end, I'm going to skip for a second for a slide which is, I don't know if I'm able to do that. A slide in the end regarding chunk sizes. This is a change that made it into Reef. Because the amount of work involved in deep scrub is very different from what's the effort required for shallow scrubs, and because the chunk size, if you're using very small chunk sizes, it means that we are wasting a lot of time of communication, of internal scheduling, etc., because we are spending the same amount of effort for communication regardless of the chunk size. So using very small chunk sizes means wasting a lot of management effort. It doesn't make sense to use very small chunk sizes for shallow scrubs, and this is why, since Reef, there is a separate parameter for double parameters for shallow scrubs. Now, I'm mentioning this because it's important, and because I think that once a cluster implements the mclock scheduler, you might want to even play with those parameters further than what we did. The set of the very conservative set of parameters we are set as default. Okay, that's a side note, but let's get back to where we wanted to be. So I don't have the side, the way to navigate it in any other way here. Okay. So let's get to the main track of if funny way of doing things. Let's get to the main track, which is this. The part where the OSD selects what PG it wants to scrub next. This happens in the tick. There is a randomized value that means that it doesn't happen every tick. Probably you know about it. Doesn't matter a lot. Scrubs don't take a second or two, which doesn't really matter. How is it performed? Remember that scheduling decisions are made OSD by OSD. We do not have a cluster-wide central scheduler. And we don't want to have it. For various reasons, mostly because it adds complexity, and because we think we can achieve most of the optimization that is achieved by having such a central scheduler. And I know we do have clients that have this, that have created such a scheduler. We think we can do something similar without resorting to that. Now, I'll try to speak faster because I'm seeing where I am and where the slides are. So let me know if my accent, if I'm losing you. Okay. We have what complicates matter is the fact that we don't want to be a burden, too much of a burden. Like I said, this is less critical in the next version. So I'm not showing you this because you need to work on the code again. What I wanted to show here is just the basics, and these basics are still there. The OSD maintains a queue, an order queue today. The OSD maintains a queue of those PGs it owns, which means, it's their primary, which are waiting to be scrubbed. And those are today sorted by one item, the target time, when we have calculated the next scrub to happen. Now, how do we do that? Each PG is since times begun, each PG holds a set of flags. And those flags, if you looked any time at scrub logs, at Ceph logs, you notice those flags appear directly in the logs. So this is why I feel comfortable showing them. You noticed them before. And those flags like rec scrub, must scrub, whatever, all those are flags that are set for various events, various requirements that are made on the next scrub. And when time comes, they determine what is the target time and what would be the attributes of that scrub that will happen. Okay, this is a set of flags. It was always there, and like I said, it determines both the order, the queuing priority, both and the level, deep or shallow, and the type, the attributes that will accompany the scrub when it will be initiated. Okay. Now, okay, I said this. What I'm trying to say, there were many changes and refactoring done to the way the code is constructed, the code around scrub in the last couple of years. We didn't change this basic mechanism. We have a queue, we have the flags. The flags are known and people see them. And it works. So there are some problems with this system. One, just to mention one which is just a nuisance, the decision whether the PG that is top of the queue will be deep scrubbed or shallow scrubbed is a just-in-time, a last-minute decision today. Because we have a randomized factor that is applied when the PG is selected and might upgrade a shallow scrub into deep. There are good reasons for that. If you, probably most of you weren't here 2 days ago, we discussed this, but there are good reasons for that. But it means that I can never tell a user this PG, when it will be scrubbed, it will be a shallow scrub. I can only afford some guess. Okay? And it is a major complication in the code. That's a point to need to be made. Now, more important is the set of flags. Here, just again, you don't have to, unless you maintain the code, you don't have to read those flags. But here is the set of flags that each PG maintain regarding the next scrub to be performed. A lot of details here. I'm very proud of the fact that I actually got, when I started refactoring code, I wrote the comments that explain what those flags are. It took me time to understand. But it worked, like I said, it works. Scrub code was written by very capable people. Sage, Sam. It was maintained for many years by David Zafman. The people who know what they're doing, and it works and worked pretty nicely with very limited number of bugs for many years. Again, I contributed to the bugs for a while, but I am trying to improve a few things. What I'm trying to improve is listed here. First, there are some cluster-wide effects that are caused by the fact that we are per OSD scheduling and not cluster-wide. We have sometimes in some bad situation, in some strange coincidences or events, we might have, and I have bugs open on me with this, we might have long tail of PGs that are waiting to be scrubbed and are not scrubbed in time. There is some problem with observability, knowing for the operator to know what will happen next, and where we are standing, what would be scrubbed and what not. And there is a major problem of code maintainability. It's hard and it's slow. It's not that hard, but it's slow to perform any changes. But when you're trying to maintain the behavior of each configuration, each configuration in these metrics of multiple flags and events, trying to match it bug to bug to what it was before factoring. And we do have a specific problem that I'll go into in a second. So what we are doing in Squid? Sorry. First, we will be scheduling scrub targets. The OSD will no longer maintain a queue of just PGs. It will be a target, and a target will contain is a piece of data. Let me A scale target is a piece of data that contains all the information required in order to know what will be scrubbed, the type, the level, all the attributes that are required to know how would that scrub look like. Okay? Which means that a PG, you don't have the internal, the specific structure is not important, but the scrubber, the PG, has a structure that holds two targets, one for shallow scrubs, one for deep scrubs. Each of them is scheduled independently because they are, basically. Shallow scrub and deep scrubs are scheduled based on their own timestamp. Last time they was, apart from the obvious fact that if you perform the deep scrub, it also counts as a shallow scrub. But apart from that, they are separately maintained. And it means, for example, that now when you are looking at the scrub queue, you know the top, you know, for example, that the next PG 3.1, the second line there, the next scrub of that PG will be a deep scrub, but in the first one, in the next one of the 1.7 will be a shallow, not a deep. I'm getting rid of this specific randomizing factor. Okay? So, at least one thing that we achieved here is more clarity, and for me, a simpler code, which is good. So but that's not enough. Let's get back to this table of triggers or types of scrub. And let's notice a few things here. We have, on one side, we have the frequency. These are frequent, hopefully. Usually, like I said, what you see is what you expecting to see in a cluster are the periodic scrubs. But we have a different scale, which is the urgency. I'm using urgency instead of priority simply because priority is way, way, way overloaded in scrub documentation, scrub code, so I needed another word. Urgency made sense. It's priority, more or less, but more than that. Okay? So what we did, and you can see it here, we have translated the trigger, the type, which is the same, into, we mapped it into a set of urgencies. One attribute that tells us almost all we need to know about the next scrub to be performed. Okay? We placed, actually, in the new code, the whole structure of those flags is removed. It's not there anymore. The logs will look different, as I'll show in a minute. And we have replaced, we have introduced this urgency parameter. And now the queue of jobs, of targets, scale targets, waiting to be scrubbed, is sorted first by urgency, then by target time. Okay? Now, that's not in. We also, by the way, have the deadline, the same deadline that we have today. I'm not going to go into that. We don't have the time. But there was one more thing that was required, we need to add, and that's the concept of not before. Why do we need that? Suppose, in this example, 1.1 is the next to be scrubbed. Okay? It's top of the queue. OSD will reach it in the relevant tick, and it will be selected to be scrubbed. But when checked, it would be determined that it's not ready to be scrubbed. Okay? There are many possible things that might block a PG from being scrubbed. For example, it's not clean, or whatever. So the PG, the OSD will select the next. That makes sense. But the next time will come to, the OSD will visit this queue of things waiting, of targets waiting to be scrubbed. That 1.1 is still there, which doesn't really make sense. We are wasting time on repeating the checks. Now, wasting time in scrub is not a real issue. This management is neglectable compared to one I/O operation of a client. Okay, that's not really the main. I think it's the more important problem is first, it's how to read the logs. But the real problem is that in some cases, it's a real problem. It's a real logic problem. I'll show you that in a moment. So what we want is a way to say 1.1, yes, it is the high priority, but there is a problem with it. Don't retry it for a while. Okay? We didn't have this before, and currently you'll see the same top retried and retried again. Okay. Could we change the target time? Push the target time forward? We better not, because we will be losing the relevant priority, relevant urgency difference between the various scrubs. If a PG was supposed to be scrubbed a week ago, and all the rest of the PGs in the OSD was scrubbed just an hour ago, I don't want it to be scheduled in the back of to be pushed to the back of the queue just because he had a momentary problem that he was doing some recovery operation or whatever. Okay, so I don't want to trick the target time. I want to treat the target time as a fixed quantity until the PG is scrubbed. So what we added is a gate mechanism. We are assigning a not before attribute, which usually starts equal to the target. It's not a sorting key. It's just a gate. Once a PG fails, is a candidate for scrubbing, tries to scrub, fails, because specific whatever problem it encounters, we are modifying this flag. We are modifying the time and push it a little forward. Okay, the idea. So it's not, like I said, it's not a sorting mechanism. We have actually a queue of those PGs that are eligible to being scrubbed. But once you're tried and failed, you're pushed aside for a while until that not before is reached. And there is a set of configuration options which I don't think a user should touch, which say, and we will need to invest time in analyzing logs and seeing exactly how to tweak those, but our best guesstimate for how long is does it make sense to push forward or backwards in English, to push to the future, the next availability, the next time this PG will be ripe for scrubbing. Now, this is an example of how a query command will look like in the new implementation. You can see here the scrub part. You can see the stamps, the sched time, the deadline, and here you can see the two targets, the shallow target and the deep target. Okay? And for convenience, you also have the nearest, which is one of them. This is just a convenience for some tools that need one. And you can see here all the data that I talked about, all the attributes, the level, the ignore this will not appear, this will change, the urgency, the target, the not before, the deadline, etc. Okay? This is how more or less, because this is not the way, there are some fine changes from that version, but this is more or less how you'll see things. And in the logs, instead of those flags that appear there forever, now you see something else. If there is a scrub for this, if a PG has a scrub in its future, and you always have, always have, if it has a scrub which is not a periodic, regular scrub, you'll see a mention in it here. Next scrub is a shallow scrub, and it's operator triggered. An operator issued a command to trigger this, the next scrub here. Okay? And while scrubbing, you'll see differently the same parameters as they apply for the running scrub. We are left with this. I try to. We have a specific problem that a specific hairy problem regarding reservation failure. Now, it's hairy and it's problematic mainly because the way the code is structured today or forever. Okay? But like I said, suppose we are asking, suppose a primary asks its replicas to reserve resources for scrub of a specific PG. Today we have a setting, Ceph-OSD max scrubs, which by default is set to 1, which is low. And with the DM clock, I would strongly suggest playing around. Already have big clients that modify that even without the DM clock. I strongly suggest increasing it a bit. We have a limit of the number of simultaneous scrubs that are performed on a specific OSD. And today we are counting both shallow, both deep, as a primary or as a replica. All are counted towards this limit. Now, in Quincy, suppose in our case, OSD4 asks to reserve replicas, but the OSD2, let's say, is doing a scrub of its own. We won't be able to acquire those resources. And what will happen? The scrub will fail. And, okay, that's normal. The problem is that that PG.5 is still in the top of the list. But because of the quirks of the implementation, the message from the other OSDs, the rejection message came in a different, it's asynchronous to the request, to the actual decision to select a PG. We are no longer, when a few milliseconds maybe, after we initiated the scrub, one of the OSDs denied that request, we are no longer in the context of an OSD going through the queue and selecting a PG. The selection has already been made. A PG has started to scrub. So what happens? No scrub will be performed, which is okay, but 2 seconds later, that same OSD will still see the same PG at the top. And that was the situation before Pacific. So we came up with something in Quincy, and still available, still applicable to Reef. If there is this type of failure, reservation, we have a penalty bench for PGs that failed in this regard. Their priority is limited to the lowest possible for, let's say, 5 minutes. Okay? This works more or less. There are some conditions that it might not, that might cause problems even with this solution. And it adds some complexity, but it's a must in previous versions. But now we have a new mechanism that we might use instead of this penalty mechanism. So we are removing this mechanism. I don't know if you're aware of that. It's there in the latest 2 versions, but we are removing that mechanism and the associated parameters. We are using the not before mechanism first. We're using the not before to guarantee some delay in the case of this failure, and the delay will be pretty large in that case. But the major change that helps us solve this problem is that we have extended the initiation process to include all those retryings, async retryings. The OSD will not stop retrying to find a PG to scrub just because the PG was instructed, go and do your job. If that PG failed, even asynchronously later on, the process for selecting the next PG to scrub will continue. It does add some complication, but it adds some code complications, but it solves so many logical problems that it's really worth it. It makes things saner in the selection process. And a minor change, we are modifying the way we manage the reservation budget or the scrub budget a bit. Today, like I said, we have one counter, everything counts towards it, which doesn't really make sense because shallow scrubs and deep scrubs are very different in the burden they place on the system. And also, there is some difference between the burden that is placed on the system on an OSD, depending on whether it is acting as a primary or a replica. Less than the other, but there is a difference. So what we'll do is create separate counters. Now, I'm not sure that we'll make all those available outside. Maybe it will be there will be a way to calculate one from the other, or some way to. But basically, it will be different counters, different weights for calculating this. And another important change: once you are performing a high priority scrub, which usually means an operator command that triggered operator triggered scrub, you will get your resources, replica resources. We won't block a replica from helping in scrubbing an OSD instructed scrub, and we are counting on the operator not to overburden, to know what it's doing. I'm glossing over things because it's not always an operator that is a trigger for high priority scrubs, but that's the idea. So all these changes, and I would, like I said, I don't think OSD max scrubs in a real, today should be 1 unless you find it that you really need it to be 1. That's another issue. But all those changes will make it easier to perform, to control how scrubs are scheduled, hopefully. Unfortunately, not in Reef, but code is very close to it was almost there in Reef. Questions?
How much of a performance improvement do you see from the queuing optimizations?
I didn't test the queuing. I did measure, by the way, the chunking. Mm-hmm. It's for shadow scrub. It does have a major effect. This is what I forgot to say. Yeah, there is the chunking has using large chunks for shallow has very observable effect. I'm not sure there is. You can talk about performance in scheduling because it's not an issue of performance. It's just an issue of how. Probably I would more likely to compare how uniform our scrubs.
Yeah, I used the wrong word.
And no, I didn't have when I had a working code ready. I didn't have working cluster, big enough cluster to test. That's why it didn't make it. One of the reasons it was part of Reef because what the problems we had testing. But I can't say.
Could you speculate if it would be difficult to add scrub for OSD? I'm asking for from an object store level. Even if you scrub for each PG separately, there still could be some elements that are just object store level, the metadata level that I use in Blue Store to maintain. And I'm thinking now, just listening to your presentation, that it might be worthwhile periodically just to check if I did not lose some object, like stray objects, some extra blobs, some internal inconsistency that basically give your objects for a scrub as clean, but underneath there is some rot going on. Could you think if it's possible to like some extra OSD scrub level item?
Well, something similar was asked when we had problems in the snaps DB that I mentioned. It's similar in a way. There was a specific bug in the upgrade from, where was it, from O to P, I don't remember, that caused defects, caused data corruption in the snaps data DB.
Snap after you got lost its entries. That was
yeah.
Right. So can you
So what I'm trying to say is, and then we added to scrub some checks to this, but again we were limited by the fact that we are coming, scrub always starts from known objects and checks the data. Not what.
It's exactly the other part I'm asking.
Yeah, exactly. And we were faced with the same issue. Shouldn't be there a process that goes from the data that exists, even if because of a bug, because of a problem, there is no owner, there is no a garbage collector or what, or garbage tester. Okay, I think there should be, and there are plans. For example, in this, in the case that I mentioned, it's in the plans to have this.
Okay.
But it's not, because it doesn't fit with the main loop of actual Scrap, which is go over objects and chunk them, and I'm not sure
So
how much
don't
of
have
the
it yet
infrastructure
in the pipeline. We don't have it yet in the pipeline to just have some like meta scrap, meta PG scrap, or whatever it could be.
No, but I think we should have. But I was wondering, we discussed this. I was wondering what of the infrastructures that it was already built can be used, can be reused. I don't think we need to build a whole infrastructure just for that again.
I think the time is.
But nobody is knocking on our door, so.
There's a coffee break.
Ah,
Now
okay.
coffee break.